biodeposit technology for the restoration of Lake Chad and implementation of the Great Green Wall project. Lake Chad is the biggest natural lake in North Africa, with an area of more than 10,000 square kilometers, and plays a very important role in the life of this region. Beginning in the 1970s, the lake drastically decreased in both its area and water capacity, losing as much as 95% of its surface area. Now, Lake Chad is mostly swamp or marshland. The drastic reduction has been labeled an ecological catastrophe by the UN Food and Agriculture Organization. The question is, how do we stop the disappearance of Lake Chad and return the surrounding region to their sustainable ways of development? By examining the genesis of the lake, we can understand what to do in order to restore it. Every lake has various periods in its life. One of these periods is the period of pond silting. Silting is the natural process of accumulation of sediment at the bottom of standing body of water. The process of sedimentation inside a lake body happens very slowly, occurring over hundreds or thousands of years, with the sedimentation accumulating at a rate of about 1 millimeter per year. Inlets to bodies of water such as rivers can increase the rate of this accumulation. The real threat that sediment brings is that it creates an environment that supports the growth of green mass. Green mass are fast-growing in shallow water at a depth of 2 meters or less. So, as the sediment increases, water depth decreases and the growth of green mass accelerates. This process can be corrected through desilting. By desilting the bottom of the lake, the depth will increase 3 to 4 meters and the green mass will decrease. These steps then increase the surface area of the lake. Biodeposit technology has been used in Latvia in National Park in Lake Ubagovas that was experiencing the silting, green mass, and surface area reduction process. By desilting the lake with the biodeposit technology, this process was stymied and the restoration process began. Sediment from the lake bottom is rich in a variety of macro and micronutrients, biologically active ingredients, and can be used as a natural organic fertilizer named Biodeposit Agro. It is used in agriculture and can be deployed for projects such as the Great Green Wall. The Great Green Wall project covers an area of about 12 million hectares. Each of these hectares will require 1 ton of Biodeposit Agro fertilizers. Dredging only about 3 meters of sediments from the lake area of 10,000 square kilometers would yield 30 billion tons of Biodeposit Agro fertilizers, more than enough for the Great Green Wall project. The additional sediment from Lake Chad can be used in agricultural sectors to increase fertility and arable land and decrease irrigation water by 4 to 5 times. The realization of the restoration of Lake Chad and the fertilization of the Great Green Wall area requires the following. 1. 7 factories constructed for dredging Lake Chad sediment and producing Biodeposit Agro. 1 in Cameroon, 2 in Nigeria, 1 in Niger, and 3 in Chad. 2. Each factory requires about $40 million, totaling about $280 million for 7 factories, with a capacity about 1.9 million tons of fertilizer per year, and can fully support the needed fertilizers for the Great Green Wall over its 7 to 8 years of implementation. 3. The selling price per ton of these fertilizers is $300 per ton. As the factories will produce 1.9 million tons of fertilizer per year, the yearly profit from this project will be approximately $380 million per year. Using biodeposit technology for the restoration of Lake Chad can assure the fast implementation of the Great Green Wall project and can help this region to apply the sustainable way of development.